Hello everyone. In this video, we will be finding the solution on an algebraic function using the Newton-Raphson method. The Newton-Raphson method has a formula given x sub I plus 1 is equal to x sub I minus f of x sub I over f prime of x sub I. The algorithm of Newton-Raphson is number 1, select a point x sub 1 as an initial guess of the solution, and number 2, for I is equal to 1, 2, and so on until the error is smaller than a specified value. Complete x sub I plus 1 by using the formula given and written here in the whiteboard. So we will be repeating the steps given in the algorithm until a specified tolerance or error bound is complied. Like what I've said in the previous videos, we will be solving just only one equation across the 4 different methods in finding the solution of an algebraic function. This is x squared minus 2 is equal to 0. Simply, if we rearrange the equation, or rewrite rather, we will be arriving to x is equal to square root of 2. So we will be finding the value of square root of 2 using the Newton-Raphson method. So what you see on the screen is the table for the Newton-Raphson method, so we can see the values properly arranged. We have the iterations, the value of x sub I, the value of f of x sub I, f prime of x sub I, and x sub I plus 1. We'll be solving for the first iteration. So the f of x is equal to square root of 2 minus 2. Then the f prime of x is equal to 2x. Using the formula given by the Newton-Raphson method, we will be finding the solution for the equation. We will be predicting the value of x sub 0 as 1. So from the value of x sub 0, we will be forming the table for the Newton-Raphson method and therefore finding the solution. So the value of x sub I, as you could see on the screen, will be 1 because that is the value of our x sub 0. Then here, the function of x sub I, simply we will be inserting the value 1 into the equation x squared minus 2, which is negative 1. So now we have the value for our f of x sub I. Now we will be finding the value of f prime of x sub I using this equation. So 2 times 1 is simply 2. So what you see on the screen right now is that the x cell automatically computed for the x sub I plus 1. But we will be doing the method here on the whiteboard manually for us to see how it really works. So x sub I plus 1 is equal to, what's our x sub I? 1 minus, what's our value of f of x sub 1? That is negative 1. And then, what is our value for the f prime of x sub 1? 2. We will arrive simply to the answer 1.5. Our accuracy for finding the solution for x squared minus 2 is 4 decimal places. So we will be putting the value 1.5 into the column x sub I plus 1. We will be repeating these steps until we have arrived to the proper accuracy of the solution. So the x sub I plus 1 will be our new x sub I. Simply copy that here, 1.5. So we will be inserting again the value of x sub I into the f of x. So we can find the f of x sub I. So 1.5 squared minus 2 is equal to 0.25. F prime of x sub 1 is equal to 3. Therefore, we will arrive at the x sub I plus 1 is equal to 1.4167. If we continue this trend or these steps, I have already pre-computed the values, so if you want to get the values by yourself, do it at home. And so you could practice the Newton-Raphson method. So here, you can see now that at our third iteration, we have arrived to the solution for the x squared minus 2, which is 1.4142. This is accurate up to 4 decimal places. Why don't we try this? So x squared minus 2 is equal to 0. 1.4142 squared minus 2 is equal to 0. So moving the 2 on the other side, and then we will now be solving for this value. So 1.4142 squared is equal to 1.9999. So they are actually nearly equivalent to each other with an error of 0.0001. So at this point, we have just solved it.